right, everybody say hi, Jalen.
Are you dying?
No, she has an appointment or something. Anyway.
Yeah, exactly.
5. Probability of the multiplication rule. If you want to use your cheat sheet, you sure can. Multiplication rule. Let's review over the 2 things that have to take place in order to multiply. Multiply. You know you are multiplying when something happens. It's an and. There's 2 or more events. 2 or more things happening. 2 or more events, and it is an and. An and separating them. Okay? This is how you know when you are multiplying. Okay? A compound event just means 2 or more events. 2 or more simple events. And then you'll have things like independent events or dependent events. Okay, and that was the 2 subcategories underneath of multiplication that we put, and let's label them. So independent, you will either have these 2 things happen. Either you have 2 events that are unrelated, or you have with replace. Okay? 2 events that are completely unrelated, or you have with replace going on. All right? And like example of 2 events that are completely unrelated would be like rolling a dice and then flip a coin. Right? We don't have to subtract 1 from the bottom number if we're rolling a dice and then flipping a coin, right? Those 2 things are like 2 separate things that we're doing kind of together. That's 2 unrelated events. That is independent, okay? They don't have to say with replace there because you're doing 2 different things. Dependent will only ever be without replace. So this is without replace, and they will say that. Without replacing, or they'll say like you're not putting it back in. That means without replace. Dependent events, that's what will happen. Okay, happy with that? All right, here's what I want you to do. On example 1, it says determine whether the events are independent or dependent. You can put an I or a D and go through A, B, C and label them. You don't have to actually solve it because they don't really give you numbers to solve. Go ahead and label A, B, C as I or D. Go. Jake's done. A, 1 coin lands heads up and then the second coin lands tails up. What'd you get? I. We didn't like shave a section of the coin off that makes it easier or harder to get a heads or a tails. So independent. B, 1 student's name is chosen from a jar, not replaced. I don't have to read the rest. Not replaced means dependent. Both Wednesday's lottery numbers and Saturday's lottery numbers are 1, 2, 3, 4, 5. When they draw out lottery numbers, do they put them back in after the next lottery? Right? They put them back in, so it is independent, yes. They throw the balls back in before they do the next lottery drawing. Okay, so that one might have been a little bit trickier if you don't know how lottery works. So anyway, example 2, on each turn of a board game, a player rolls a dot cube. That's the first thing that they're doing is rolling a dot cube, and then they're spinning a spinner. So first thing to happen, second thing to happen. On Dion's first turn, he rolls a 3, and then the spinner lands on red. Are these events independent? Are they independent of one another? Rolling a dice and then spinning a spinner? Yes. And then they say, explain using probability. They just say, find the probability of that happening. So the first thing he wants to do is, what? Roll a 3. That's the first thing that we're doing. Rolling a 3, and then we are spinner landing on red. Okay, so this is how I set it up, and then I can't go wrong. Rolling a 3 and then spinning a red. I know I'm multiplying in between them because I'm doing 2 things. And rolling a 3. Chances of that happening. 1/6. Rolling or spinning a red. 1/3. And I multiply the tops and the bottoms. And 1/18. So they say explain using probability. Just find out what the probability is. So yes, it's independent, 1 over 18, done. Okay, we just did that, 2 independent events, you're just multiplying the probabilities together. That's what this little box is saying. If they're independent, you just take the probability of each one, multiply them together, done. Okay, all right, example 3. Marisol and her friends are going to a concert. They put 3 blue and 5 yellow slips into a bag. I'm going to label this down below. 3 blue, 5 yellow, which makes a total of 8. I know they're going to ask me that, so I'll put them down below and then I don't have to reread. If a person draws a yellow slip, it means that they are going in the van. If they draw a blue slip, that means they are going in the car. That's what those things mean. Suppose Marisol draws a slip. Not liking the outcome, she puts it back again. What does that mean?
It's in your place.
Yes, replace. Yes, replace. She's putting it back in again. Okay? Now, if she's smart and she doesn't like her outcome, what would be the better idea?
Just keep it out.
Keep it out, right? Because then you have a higher chance of getting something that you do want, right? If you put it back, you could end up drawing the same slip again. That stinks, right? What?
She's not smart.
But she's not smart. So, not liking the outcome, she puts it back. What is the probability that on each draw her slip is blue? So basically we want a blue and then another blue, and since we're drawing more than one, we're multiplying in between. And yes, we are replacing.
So 1/3 and 1/5.
So blue, how many blues are there?
3.
3 out of 8,
Oh.
and then another blue again, if we are replacing. 3 out of 8. 3 out of 8, 3 out of 8, 9 out of 64, I think. Yep.
Yeah.
Yep, those are her chances. You can leave it as 9 out of 64. You can convert it to a decimal or a percent. I don't care. Okay, happy with that?
Yeah.
Beautiful. Okay, backside. Probability of 2 dependent events. They write it like this. They're just saying the probability of something happen over the probability of something happening given that something else is happening. Usually it involves subtracting the bottom number. Subtracting from the bottom number. Okay, so we have like 1 less. We only have 51 cards instead of 52, etc. Okay. All right. Example 4. Cynthia randomly draws 3 cards this time. So we have 3 things going on, which is okay. From a standard deck, 1 at a time without replacing. That's a key word. Without replacing. Find the probability that the cards are drawn in the given order. What do we want to draw first? A diamond, then a spade, then a diamond. So I have 3 fractions that I'm putting together. A diamond is one of these guys. A spade is one of the shovel-looking things like that. And then another diamond. Diamond, spade, diamond. That's what we're trying to get. Okay? How many diamonds are there in a deck?
No. 13.
13. 13 diamonds. 13 is a suit. 13 out of 52, which we're going to reduce here in a second. Okay? And we are not putting them back. Keep that in the back of your mind. Not putting them back. How many spades do we have in the deck? Still 13, because we're assuming that what we drew here was in fact a diamond. Does that make sense? We're assuming that what we wanted to draw was a diamond. Okay? So there are still 13 spades remaining out of 51. Okay, diamond. How many diamonds are there?
12.
Now there's only 12. So this is the only case where you subtract from the top number also. Right? Only 12 out of 50 this time, and then let's reduce. Okay, so I know that 13 and 52 is 1 over 4, right? Because there's 4 suits. Okay, what else can reduce?
4 and 12.
4 and 12 can become 1 and 3. Okay, what else? I think 3 and 51 will reduce. Take 51 divided by 3. I think it's 17.
Yeah, 17.
Yeah, so 1 and 17 like that. Okay, and 13 is prime, and I don't think 13 goes in any of those. So on the top, I have 1 times 13 times 1. So just 13. Okay, on the bottom, I have 1 times 17 times 50. Is that right? Yeah, that's right. 17 times 50? 850. 13 over 850, and there's my chances of that happening exactly. Good chances or not good chances?
Not really.
Not really, right? 13 out of 850 is less than like 1%, probably. Like really small. What is that as a decimal?
Oh, it's like
0.015?
1.5%.
Okay, so 1.5%-ish, something like that. Okay, not real good chances of that happening. Still possible, but not real good chances. Okay, good. Last thing, in a carnival game, 3 cards are marked with a star. I'm gonna put 3 stars down here. 3 cards are marked with a circle. So there's 3 cards with a circle, making a total of 6 cards. Okay, all 6 cards are placed face down. So we have 6 cards. 1, 2, 3, 4, 5, 6. You guys have played this before. It's the memory game, right? Where you flip one over and then you flip the other one over. Okay. It says if the first card is a star and the second card is a circle, the player wins a prize. So we're trying to get a star and we're trying to get a circle. That's what we want. We want a star and then a circle. And we're multiplying in between because we're picking 2 cards. Are we replacing or not replacing?
Replacing, because you just put it back down if you don't get it. Well,
No, but you don't, in memory, you don't pick up the same card again.
Right, so it does not say that we're putting it back, right? If the first card is a star and the second card is a circle, you pick them kind of both up at the same time. So this is going to be without replace. It doesn't specifically say that, but you have to kind of search for that information. So without replace, we have to make sure we take that into consideration. It says Alec decides to play the game only if he has at least a 25% chance of winning. He will play. Should he play the game? Let's figure it out. So we have to have at least a 25% chance or he's not going to play. What's the chances of me getting a star first? 3 out of 6. What's the chances of me getting a circle then after that? 3 out of 5 because we're not putting it back, right? But there's still 3 circles, but only 5 total cards, okay? 3 out of 6 can reduce to 1/2, right? And then that becomes
1 out of 25.
3 out of 10. 3 out of 10. 2 times 5?
Oh.
I think you're trying to square.
Yeah.
3 out of 10, which is 30%. So should he play?
Yes.
Yes, 30% is greater than 25. So yes, play. Make sense?
Yeah.
Okay. You guys are going to get stuck on number 20 on the homework assignment, so just save that one for tomorrow. You can read through it and you can try to get it. But number 20 is going to give you kind of a tough time. Okay, we'll do that one tomorrow.
No idea
Okay.
where my cheat sheet is. Is there any way I could make another one real quick?
Sure.
I'm gonna check a couple other places, but I have no idea where.
Sure. I can try to maybe print one too. Okay, everybody say bye, Jalen.
Bye, babe. We love you.
Bye. Don't die.